In this lesson, we are going to talk about physics. Physics is one of the coolest features you can add to a 3D website because people just like to see things fall apart, collide, jump, bounce, and stuff like that. Just look at Angry Bird. Angry Bird is great, it's funny because you can destroy a castle by sending a bird into a structure, stuff like that, and you can see the effect, the things falling down, which is really funny. I have another good example. Obviously, it's my portfolio. As you can see on my portfolio, just a quick check. You can destroy almost everything. You can go into the walls, stuff like that, and destroy stuff, and it's satisfying, and people just like to do that. I really like doing my portfolio because I was always playing, trying to destroy even more stuff. And so yeah, let's go. Let's try to learn how to do those kinds of physics with 3GS. I will have other examples to show you. You can create your own physics with some mathematics and solution like recaster. Maybe you can cast a ray in direction of the wall. If the wall is too close, maybe you should bounce, so you have to calculate where you're supposed to bounce, stuff like that. Well, it's a lot of work, but at least it's possible. You can do it. But if you want like realistic physics with tension, friction, bouncing, constraint, pivot, and be able to tweak all of those, well, it's better to use a library. And in this lesson, we are going to use a library. So let's talk about theory first, because we need to understand what we are going to do. The idea is that we are going to create a physics world, and we are going to create a 3GS world. In here, we already have our 3GS world, all right? So let's do some drawings. It's not that important here, but anyway, it might help some of you. We have our 3GS scene that looks like this. All right. Inside that scene, we have our cube. We have, let's say, a sphere. We have stuff like that. The sphere is a little higher. All right. For now, nothing is moving. We are not animating everything. The idea is that we have our 3GS scene here, and we are also going to create a theoretical world, a physics world, and we cannot see this one. All right, it's just it exists. There are things happening here, but we don't know. We cannot see it. And when we are going to create the floor, a cube, a sphere, stuff like that, we are going to create the same thing on the physics world at the right positions, and maybe we have a sphere on the top. And on each frame, we will tell this physics world to update itself. All right, it's going to be the code inside the library that we are going to use. And this code will tell, well, the ball will just follow you. So the ball will be there. And then on the next frame, there. And then on the next frame, it will bounce on the corner. So it will get there and there and there and fall. And like that, it goes on and on. And on each frame, we update this world. And we take the coordinates, let's say, okay, this is the new coordinate, and we apply those coordinates on the 3GS world. This way, we update our sphere and we put it there. So I will use the same color, I'll use this one. On the next frame, my third frame, we take the coordinates. So it might be over here. Oh, sorry, it's a little on the side, so there. And then on the next frame, we take the coordinates. And we update here, so the balls get here, here, etc. All right, on each frame, which is a lot of work, but don't worry, your computer can manage at least few objects bouncing around and do 3GS and the physics library. That's all. We just need to duplicate things inside that physics world, and on each frame, update the physics world, take the coordinates and put them back on our 3GS object on the left here. All right, so this one is the 3GS. And this one is the physics. All right, we don't know yet which library we are going to use. Anyway, let's talk about just physics. Okay, cool. Let's move on. Yeah, as you can see, it's not that hard. The theory is not that hard. The problem is organizing our code. How do we create objects on both worlds, then update them on each frame? And what if we want to add, I don't know, dozens of objects? Do we have to create each one on each side and then change their friction, material? it can be a mess, and I'm going to show you some tips to be able to do it properly. So yeah, let's go. First, we have to choose the right library. And this is very interesting because there is many libraries to do physics. And the first thing you have to choose is, do you want a 3D library or a 2D library? Well, we are doing 3GS, it's in 3D. We are supposed to use 3D library, sorry. No, because you might be able to reduce your physics to 2D physics world. Let's think of a pool game. A pool game, so it's in 3D. You have your pool table. I hope it's the right word. Let's say it's a pool table. Looks something like that, something like that, something like that. All right, that's cool. It's okay, at least. So we have our thing here, here, here. We have the balls inside of it. So I'm going to use, I don't know, maybe this one. There. All right, I won't put all of them. And then you have to play. So you have the white one here, and you have to push it with the I think we said the Q to play this pool game. All right, so if it's in 3D, I can go around the table. I'm going to use a 3D physics library. Not necessarily. You can use a 2D library and reduce this world to 2D axes. Let's say we have, I don't know, just a 2D thing like this, and you will have those balls. So it's seen from above, sorry, like this. You have the white one, and you will have to push the white one with the cube, like that. So we reduce this 3D experience to 2D physics, and it's better for performances. And I have good examples of great projects done like that. I almost did my portfolio like that, but I wanted to be able to jump with above the object, so I had to use a 3D library. But one good example is We Go Let's Play by Merci Michel, one of the greatest websites ever, because it's just so cool. Like, it works so well. I'm going to put in full screen so you can enjoy. And as you can see, this is a 3D world. So it's a pinball. We have to launch the ball and then play with it. Press space, push it, and let's go. And I'm really bad at those kind of games. But anyway, look at the physics. We have a 3D world. We can take the I don't know how you call them, the slider on the left, right, stuff like that. I've been lucky right now. Oh, there is one stuck. Okay, that's unlucky, but I don't know why there is this one being stuck. Maybe I have a problem with my my keyboard. Yeah, anyway, we have a good preview here of an example because the physics is being done only, oh, now it's working. Okay, great. The physics is only done with 2D. And they reduce this 3D world to 2D. Yeah, the ball cannot jump up and down, but still we have the feeling of 3D. All right, I will stop. Great. Let's get back to our physics lesson. Okay, cool. We have many physics libraries. We have access to AIMO.js. So this one is pretty famous. We have Canon.js. We have OIMO.js, very great. And we have many other. These three, I think, are the most popular ones. We're going to choose one bit among them. I won't tell you exactly the difference between those. We will talk about those two, but in the lesson, if you scroll down, you will have all the details. All right, I put all the links and all the differences between each one of those. So you can choose yours. We are going to choose one for this lesson, but if you want to make your own mind about this, you just have to scroll in the lesson and I put all the details. I won't tell it there because it will be too long and not very interesting. If you want to use 2D physics library, you can use Matter.js, P2.js, Planck.js, Box2D.js, and there is many more. All right. Yet again, scroll if you want more details. And maybe I will update the lesson if I find new libraries. So have a look in the lesson in the text version. So there are also solutions trying to combine 3GS with physics libraries, so you don't have to do all the work we are going to do right now, like PhysiGS. I hope I say it right. We are going to talk again about PhysiGS at the end of the lesson. but we are not going to use it because I want you to understand how it's done so you have more control and you can do anything. All right. We are going to talk again about Physics.js at the end. All right. Amo.js, might be the most used library. I think it's the most used library, but we will use Canon.js because it's easier to implement and to understand. And the lesson is huge. I want it to be manageable for you, so I choose Canon.js, all right? And I've been using it a lot. It's a great library. Not perfect, you will see why, but it's a great library. So I didn't added the dependency to the project, so you can do it with me, so that you can learn how to add a physics library to a Webpack project using modules. First, you will need to open the terminal, so you can use the one that is running your server. You can kill the server, so Control C, and you can run npm install -- save Canon. All right. This is the npm library, so it's Canon.js. They call it just Canon. Wait maybe a few seconds, few minutes, pause the video. I'm going to continue. You can launch the server again, npm run dev, like that. And then you can import Canon.js. So I can refresh, it's working. And to import Canon.js, it looks like this from Canon. And you can log the Canon variable like this. All right, it's working. We have a lot of things inside. Remind me of 3GS. Remember when we first logged the 3GS library, there was so many things inside. That's the same. And we are going to use some of them and understand everything. Not everything, a lot of Canon.js. All right, the setup is quite simple. I can remove my console log. In the setup, we have a sphere, we have a plane, we have shadow working, we have an environment map too. I forgot to add it. It's just so we have something that looks great. All right, that's all. And we also have that GUI, and we are going to use it. We are going to add a few stuff inside that GUI. You can add anything you want and have fun with like the gravity, stuff like that. All right, let's start. As I said in my beautiful drawings, we are going to create a world, a physics world. All right, we already have our 3GS world. We are going to create the physics world so that our ball can fall and bounce and be pushed in directions and stuff like that. So to create a physics world by using Canon, it's probably very similar in other libraries. It is actually most of the time it works the same. We're going to create a physics part. So I put the code right after the textures. It's not that important, but let's try to do exactly like I do. So we don't have any problems like JavaScript, variable being declared too soon, stuff like that. So right after the textures, create a physics world. We are going to call it just world because we are going to write world a lot, and do new Canon world. Like this, we save, no error, looking great, cool. We are going to have the ball bounce shortly, which is great, without too much code. All right, by default, it's like empty space, like a void, and things are not falling or going up or anything. So if we add a sphere inside that physics world, the sphere will just not move because we need to add gravity. Right? You can do physics in space. It can be a great experience. I actually really want to do something like that. But anyway, let's stay on Earth and add some gravity. To add gravity, we can do world gravity, and gravity is a vec3. I didn't say vector3, it's a vec3. All right. And this is, it's the same as the 3GS vector3, but for Canon.js. All right, it's the vec3. Make the difference. I will talk about vector3. It will be 3GS, and vec3. It will be Canon.js, and it works almost the same. So we can do something like gravity. It's a vec3, and do set. And because we want things to fall down, so it's in the y-axis, but negative because we want it to go down. So it's gonna be 0. Minus 9.82, which is the gravity constant on Earth, 0. If you want to create an experience on Mars, you will have to find the right value on Mars. Okay, cool. By the way, this is the documentation. Be careful. You might have problems with the documentation because the SSL certificate is not secure. By that I mean it can only work with HTTP, not HTTPS. If you test the same with HTTPS, it will look something like that, and we cannot see. It's harder to see because the menu is at the wrong position, because the JavaScript broke, because there is a problem with the SSL certificate. Maybe when you test, it's fixed, right? It's been years that it's not been fixed, so just use the non-HTTPS, so non-SSL, and it will be fine. Don't worry, you don't have like logins or stuff like that, so it should be fine. Okay, cool. We're going to use this documentation quite a lot. So we have our world. It's supposed that we have gravity in it. Let's add an object inside that world. So let's add this sphere, but inside the physics world. We have to add other things. So how do we create objects inside the physics world? So in Three.js, we create meshes. In Canon.js, we create bodies. Have a look to the body documentation. All right, it's this one. And we can have a lot of parameters. We are not going to use all of them, at least not right now. We are going to discover them as we progress. Do not worry. Bodies are objects that will fall and collide with other bodies. All right, if you think of it like it can bounce on it or it can fall or stuff like that, well, it's a body inside the physics world. We have many shapes. We can do like a box, a cylinder, a plane, a sphere. That's the first thing to understand, is that we want to create a body. But to create a body, we need to create a shape. A little like Three.js. You want to create a mesh. This mesh must have a geometry. So you have to create the geometry first. This is the same. We want to create a body. We first need to create a shape. It's not a geometry, it's a shape. We have many possible shapes: box, cylinder, plane, sphere, etc. We are going to use a sphere. So let's go. Let's create the shape first. So we are going to add some comments because it's always good. We are going to have quite a lot of code. So hang on, add some comments. Maybe just follow me for now. So I'm going to create the sphere, and I'm going to do const sphere shape equal new Canon sphere. All right, I took it from the documentation. There is a sphere somewhere over there. Yeah, that's our sphere. Very simple, just a radius, which is why we start with this one. It's the most simplest one. We're going to add a box too, and you will see that it's a little harder. But don't worry, we start easy with a sphere. And we choose the radius of 0.5, which is the same as our buffer geometry. All right, this is the buffer geometry for the sphere we can see. So this one, we use the same radius, because if you have a bigger or a smaller physics sphere, it will look strange. Okay, cool. I think it's fine. Let's just save. No error. Cool. Let's continue. Always test if you did some errors. It's really easy to do some mistakes, some typo. So yeah, always refresh, even if you have nothing on the screen. Equal new. Then we can create the body by using the shape. So Canon body. And we can pass one parameter, which is an object. So as you can see, it's one object, like the materials of Three.js, because there is a lot of parameters. Well, let's just put an object. And we have to provide many things, like the mass. If the mass is higher and you have two elements, with one with a low mass, one with a high mass, and the two collide, the one with the highest mass, we push the other. All right, it works a little like this. This is physics. You don't have to be an expert in physics, don't worry. But this is the idea, and you will be able to play with it. And actually, you can put a tweak for this parameter. We are going to use one. Let's keep things as simple as possible. You can provide the position right away by doing Canon and a position in 3D, well, vector 3, but we are using Canon.js, so we need a Canon vec 3, just like we did for Three.js. And we are going to put it at 0, 3, 0, so it's a little higher here, because we want our sphere to fall and bounce on the floor. All right, looking good. We can then provide the shape, so it's gonna be sphere shape. This is one way of providing all of these, and we are going to discover that you can do differently. Okay, cool. Let's save. No error. Let's continue. When you create a body, you have to add it to the world. Just like we added meshes to the scene, we can add bodies to the world. So let's go. World, add body, sphere, body. Save. Okay, still nothing on the screen. Anyway, no error, which is the important part. Yeah, nothing is happening because we need to update our Canon.js world. Just like we did in the drawings, on each frame, we need to tell the physics world to update yourself. Next frame, update yourself. We won't have to update things manually. We just tell him, update yourself. I trust you, do your things, update yourself. All right, so how can we do that? It's actually a little hard because there is something really strange, which is important, but yet we will have to provide stuff that are really hard to understand. To update the world, we must use the step. So let's go to the tick function because we want to do that on each frame. And let's put update physics world. Yeah, physics world is better. Physics world. And we need to use the step function. I put a link to understand everything about what we are going to post. If you want to know more, just read the article and you will see that there is a problem that many people don't even know when they are updating things, and which is why we are going to provide a lot of parameters right here. So we need to use world step. There are easier ways to do it, but I want the best way, which is more accurate in terms of physics. And in this step, we need to provide 3 parameters. We need to provide what we call a fixed timestamp. I don't know what it is. We need to provide the time passed since the last step. All right, I know about this one, but I don't have it right now. And we need to provide how much iterations the world can apply to catch up with a potential delay. Like if the physics world is late, which you will understand by reading the article I just shown you. All the links are as always in the links panel at the bottom of your screen. But we need to tell, okay, you can do like 3 steps to catch up for potential delay. Sorry, I didn't say 3, but let's put 3. It's enough. Okay, cool. I won't explain the first parameters, but we have to provide a fixed time step. We need to just decide on a time step, and we usually just use 1 divided by 60 because we want our experience to run at 60 frames per second, and this will be a base for the physics world to update itself, and then it will potentially catch up with the delay. Do not worry, it will work the same on high frame rate screens. All right, you will get the same result. The second parameter is the delta, so it's how much time was spent in seconds with the previous tick. Sorry, I'm kind of losing myself here. So how can we calculate this? First, we are going to comment this part in order just to concentrate of this variable we need to calculate. So we need to know how much time was spent since the last tick. To do that, we first need to create a new variable, and we are going to create old elapsed time, and we are going to put 0 in it, and we are going to subtract the current elapsed time with the previous elapsed time. So to do that, we are going to create a new one. We are going to call it delta time equal, so it's the current elapsed time. So maybe we are at 1 second, so current elapsed time, current elapsed time like this, minus, so we subtract the previous one. So for now, it's going to be old elapsed time. And then we update the previous one. Once we are done calculating the delta between now and the previous step, we can update the previous state time by using the current elapsed time. You will see the result. We can log it, and we will get something like this. All right. It's how much of a second was spent since the last tick. We call this the delta. Anyway, we just need this value, and we are going to provide this value as the second parameter of our step function. As you can see, it's hard for me, all right? This part is hard, but still, if you want to understand this part, just read the article and you will see that it's to catch up with problem and have a very precise physics word update. So it's important if you want something really precise. All right. Still nothing, but our physics world is updating. And maybe our sphere is falling. How can we know that? Well, we can know that. So this is what we did. We can know that by logging the sphere position. So remember, we create, so the body sphere position. We create a sphere body here, and we can log its position, and we have access to the position just like a mesh by using position Y. And look at the result. We have a value, and the value drops like really fast. Well, it's because our sphere is dropping in the void, so it's going down like really fast, and there is nothing to stop the sphere. There is no flow, so it keeps falling. All right, that's cool. Let's use this value. I will remove the console log because there is a lot inside my console, and we are going to do what I say earlier. We are going to take the coordinates of the object and update our 3GS world on each frame. So first, we update the physics world. Canon.js is doing its things. And then here, we are going to take the coordinates of our sphere body and apply them to the sphere. So there is many ways of doing it. We can do this way. So sphere, which this one is the 3GS sphere. Position x equal sphere body position x. You probably know where I'm going here. Then the y, then the z. Let's test, and it's working. I know it's going through the flow. We are going to fix that right after, but anyway, it's updating. So congratulations, you have your 3GS world updating accordingly to the physics world. But as you can, as maybe you remember, we have access to a method called copy, and copy will copy all the values from another position, from another vector 3. And you might think, but wait, sphere body position is not a vector 3, it's a vec 3, it's a Canon.js vec 3. Well, don't worry, it will work. So this is great because you can take the coordinates from one library and put them in the other library or the opposite, and it will work. Thank you to the guys that did that in the Canon.js part and in the 3GS part. So yeah, we are going to copy the sphere body position coordinates, so x, y, and z, into the sphere position coordinates x, y, and z. We save, and with just one line of code, we are updating our sphere accordingly to the physics world. Okay, cool. Yeah, so our sphere is going through the flow, and we need to fix that. We need a new body. We need a body for the flow, but we don't want that flow to fall with the sphere. We want the flow to stay static, and we can do that pretty easily, but we are going to do things a little differently just to understand really how to use the Canon.js library. So we're going to add the flow. We can just put, I don't know, flow, and do const flow shape equal new, sorry, not 3, Canon plane. All right, we have access to different shapes. We use the sphere. Now we are going to use the plane. Then we are going to create a body, and this time we are doing things a little differently. We are going to do flow body equal new Canon body and put absolutely nothing in it, because we can change the things after the instantiation. All right, I just want to show you that it is possible. So let's do it. Flow body, we put a mass, and for the mass, we are going to use 0. And by doing this, it doesn't mean like the object is composed of air or stuff like that. It will just tell Canon.js that this object is static and won't move. Like you can launch many things at it, it won't budge. All right, cool. So mass 0. What we need to do then is provide a position. Well, we don't really need to provide a position because it's at the center of the scene, so we don't want to move it. So we don't touch the position. But still we need to provide a shape, and to add a shape, we can do floor body, add shape. All right. So the add shape method will let you add a new shape, and we're going to use the floor shape. Don't forget to add it to the world. We do world, add body, floor body. Be careful, we will have a bad surprise here. We save. Okay, something happened. It looks like the sphere is jumping like behind the camera. I don't know why exactly. I will explain to you why. But anyway, we can do that. We can update the properties after. And also, as you can see, if we can do that, it means that you can add many shapes to one body. So you can have complex body. All right, you can have a body composed of a sphere with stuff attached to him. Let's take this mug. If you want to create this mug in physics, you will create a cylinder here. And for this part, maybe you can do, I don't know, maybe a box or another cylinder. And this will be a rigid body composed of two shapes. Okay. So it's possible, we won't do it, but keep in mind that it's perfectly possible. Yes, this is exactly what I say. All right, so what is happening here? Well, if you remember from 3GS, if you don't rotate the floor, our floor is like this. So maybe you understood that we are creating a plane in CanonJS, but the plane is facing the camera like that. All right, by default. So we need to rotate it. So put back the floor, the 3GS floor where it's supposed to be. Get back to the floor body, and we need to rotate this one. Unfortunately, rotating in CanonJS is harder than rotating in 3GS because CanonJS only supports quaternion. So if you want to rotate something, you have to use quaternion. Oh, let's remove this. Sorry, it was just an example. We want just one shape to compose our floor body. So yeah, we cannot do like rotation x equal something. We need to use quaternion. So let's go. We know about quaternion. It's not going to be that hard. By the way, you have quaternion inside the documentation right here. And you need to use one of those methods to rotate your object, your body. So yeah, let's go. I'm going to do floor body quaternion. So I access the quaternion just like in 3GS. So I cannot do rotation. And I'm going to use set from axis angle. And actually there is the same one in 3GS, but we don't use it because we prefer to use rotation. I do prefer use rotation. So set from axis angle, it's kind of doing like a rotation. Let's take this guy here. The idea is that you're going to provide two values. First, an axis. It's like putting a stick through your object. So you put a stick through this object and then you provide an angle, which means you will rotate like this. All right. If I do it there, I put an axis there and then I rotate here. I can put the axis at different position like this, and then it will do a rotation like this. Okay, cool. So in our case, we want to rotate in that axis. All right. It's like the plane is facing like this, the camera, and we want to rotate like this or maybe like this. I don't know exactly. You will have to test. So the axis will be, I will put just line breaks so it's more easy to read. Vec3, and it's in the X axis. So we can do like 1, 0, 0. Actually, it's going to be minus 1, 0, 0 if you want to rotate in that direction. Actually, you can invert them, you will see. And then so use minus 1, 0, 0. So this is the axis going through the plane that currently is facing the camera. You cannot see it, but right now it's facing the camera like this. And then we can do the rotation. So let's go. Math pi. And it's going to be a quarter of a rotation. A full rotation is math pi times 2. So pi times 2. Half of a rotation is pi. So a quarter of a rotation is pi divided by 2. Okay? We did this one quite a lot. So math pi multiplied by 0.5. What do we get? Okay, it's working. What if we did in the wrong direction? So we rotated in the opposite. All right, something happened. I don't know why exactly. Well, I can tell you what happened. When you are using a plane, it's an infinite plane, and everything below is supposed to be like the ground, like dirt, like the earth, if the earth were flat. So if we put a sphere inside something which is like a filled with something, so the sphere just bounce away, maybe disappear. I don't know what exactly happened to the sphere, but it's not possible. We need to put the sphere on the right part of a plane. So this is what happened when you rotate in the wrong direction. If everything disappears, you probably placed your floor, so your plane, wrongly. So we need to provide something like this. Oh no, sorry. So it's like this. This is the right value. And actually, you can rotate in the other axis. So I revert it. Revert this one, and it's still working. So instead of going through this like that and doing this, we rotate it in this, but rotating in the opposite direction, so it's the same thing. All right, let's not talk too much about quaternion, rotation, stuff like that. I will use the same as the example in the lesson, which is like that. Okay, cool. So as you can see, it's working. Our sphere is falling on the plane. Our plane is infinite. I know that the one in 3GS is not, but the one in CanonJS, it's a mathematical plane. It doesn't have edges. It's infinite. Okay, cool. When our sphere bounced on the floor, it almost stopped instantly. All right, because it looks like it's, I don't know what material it is. Maybe it's some kind of jelly. Maybe the floor is made of jelly and the sphere is not. I don't know. And when it's fall on it, it doesn't bounce much, like not like a bouncing ball. We need to have control over this, and we need to create what we call materials. This is not 3GS material. This is not a material we'll be able to see. It's more like saying this is concrete, this is jelly, this is plastic, and stuff like that. So let's go. We are going to create them. I think we can create them. Let's do right after the word. And we're going to create many materials. You will see that it's quite a long process, but at the end, I will show you a more simpler version. So we are going to create a material for the floor, so the plane, and a material for the ball, which is our sphere. And we're going to tell the sphere that it's plastic and the floor that it's concrete. Actually, this is not really important, but you will understand. Const concrete materials. We create a material. I hope this is the way of writing concrete. New canon material. And we have to provide a name. This name is not that important, but it can help in specific situations. We are not going to use the fact that it has a name, but anyway, provide a name. Then we create a plastic material and we call it plastic. All right, and you can create any material you want. These are just references. We are not going to provide properties to each of them, which might be strange, but you will understand why. These are just references, and we will associate those with the different bodies. But then we are going to create what we call a contact material. So as always, you have the links if you want to check the documentation. And we are going to create a contact material, which will be what happens if a concrete material meets a plastic material. And this is the part where you provide the value. You provide values like friction, restitution, does it rub, does it bounce even more, stuff like that. So you create a contact material and provide the properties when concrete collide with plastic. So let's go, let's create it. We can do a const. I like to use both names inside the variable, so it's going to be concrete plastic. So it's the two we created right here. Contact material. You know, I like to create like a huge variables name. Probably not a good idea, but I prefer to have something you can understand just by reading the variable name, at least for this course. Contact material. Contact material, like this. And we need to provide the two materials. The other is not important. but let's do it like we named the variable. So it's going to be concrete, then plastic. And then you have to provide properties on what happened when they collide. And we will just see the friction and the restitution, which is the most important part. The default values are 0.3. So let's play with them. We are going to add 0.1 for the friction, meaning that when they rub, well, they get really slow fast, okay? If there is, no, it's the opposite. If there is a lot of friction, well, if, I don't know, a box is sliding on the floor, on the concrete floor, it will stop quick. But if there is no friction, it's like there is oil everywhere and the box will just, like in the cartoon, the box will just continue its way. So we will add not many friction. We won't be able to see the friction right now, but later we will. And we will add a lot more of restitution. We want our ball to bounce. When you let a plastic ball on the concrete floor, we see that the plastic ball will almost jump back at the same height. So we are going to provide 0.7 because the default value is 0.3. Okay, cool. I saved, nothing is happening. All right. I mean, it's the same result. What we need to do now is add this contact material to the world by using add contact material and provide the variable that contains the Canon contact material. Still nothing, it's the same result because we didn't tell our sphere and our floor to use those materials. So for the sphere, it's going to be inside the instantiation object. So we are going to do material, plastic, material. And for the floor, because we did everything after the instantiation, it's going to look like floor body, material equal concrete material. All right. We say to the floor that to use the concrete material. We say to the sphere to use the sphere, the plastic material. Never mind. And it's just references. And when both will collide, CanonJS will test. All right. So you have this reference material and you have this reference material. I'm going to use this contact material and it will apply those properties. I know it's far-fetched. We are going to simplify this soon. But I want you to understand and see how it bounces. It's looking great. It's working. You want it to bounce even more. Let's say 0.9. See, it's almost getting back at the same position. And actually you can have fun and do 1.5 and it goes even higher, which reminds me of this movie, Flubber, something like that, you know, with the greenish ball that leaves, and when you send it to a wall, it bounces back even stronger. So it's a really old movie. Sorry, I'm getting so old. Yeah, anyway, we are going to simplify everything and replace the two materials by just one default material. All right. And usually people just do that. If you're creating like my portfolio, remember my portfolio like this, I think there is only one material. All right. Because it's not realistic. It's just having fun, like playing with toy, like everything is plastic. I think I created only one material and used this material on everything. Maybe a different one for the floor, but all the rest was a default material. Anyway, you can just start by creating a default material and your code will be much simpler. So hang on, we have to modify those things. First, you can remove one material. Then the one you kept, you have to call it default material. You can put the name default. For the contact material, see, I'm going to change the concrete plastic part of the name and I'm going to put default. All right. Now your contact material is now called default contact material. We could have let the old variable names, but I like to have a really clean code that makes sense. For the two material here, well, that don't exist anymore. So we are going to use default material and default material. We can let those properties and we can add it to the world in the add contact material. All right. See my code. It's exactly what we did here. Take your time. We only have one material. We say that when this material collide with this material, we get those property, friction and restitution. Let's put back this one a little like 0.7 like in the example. And we add it to the world. Be careful if you test right now, you will have an error because we need to provide different materials to the bodies, so the sphere body, it's not plastic material, it's default material. And this one is not concrete material, it's default material too. I refresh, it seems to be working. And there is an even more simpler way. You can remove those. So I will remove the floor body material and remove the material inside the sphere body. So it's not working anymore. As you can see, it stopped too fast. And say to the world that the default contact material equal this default contact material. And see, it's bouncing. All right. So it's working. Great. This way, all our world will be composed of the same material. And usually it depends on how realistic your world is, but sometimes it's enough. Okay, cool. Yeah, we did that. So we have something happening, but we don't have much control over the physics. We would like to be able to push the ball or stuff like that. There are many ways to apply forces, and it's kind of a mess. These are the four methods we can use to apply force to a body. We're going to apply forces to the sphere, different forces. So hang on with me, we explain this, and at the end you will understand that we can just simplify and use only one. We have the apply force, which is self-explaining because we are just applying force. It's at a specified point in space and doesn't have to be on the body surface. Like you can have, let's say, our beautiful car. You can push it so it jumps, all right? But you can also push it there and it will do something like that, all right? So it can work to have something like that. Why not? I know it's not physically possible, but we are using code, it's JavaScript, we can do whatever we want, and we can do that. Just keep in mind that it's a point in the world. It can be like the wind, it can be, So it can be like the wind, when you push it like just a little, the wind, so if it's a ball, it will roll. You can, I don't know, push dominoes. So this is a domino, you just push it like one push at a very specific moment with enough force to enough strength so that it can fall. All right. And you can also apply like a huge, strong force at a very specific moment at the center. So the car just jump far. It can be like to create Angry Birds style games so that the Angry Birds go toward a castle and destroy this castle. So this is the apply force. We spent a lot of time on it because this is the one we are going to use. There is also the apply impulse. It's like apply force. It's the same kind of parameters, but instead of adding the force, to the force, it will add to the velocity. We are not going to explain how a physics engine works, but we can just simplify by saying when you apply a force to something, if there is nothing stopping it, it will add at the end to the velocity, right? You add force, this force creates like, let's say speed. It's not the exact term. The term is velocity. So your thing starts moving because the force will add to the velocity. All right, so we apply force, which will result in velocity, which will result in our object position being updated. If you use apply impulse, you bypass the force and apply directly to the velocity. It can be useful in very specific situations, but for me, let's use the apply force. Let's use the basics. It's the basic usage and it's logical. We apply force just like someone pushing something or the wind pushing the ball so the ball can start rolling. And we are going to use apply force. And the two next one are apply local force. It's the same, but when you provide the coordinates, it's the local coordinates, meaning that if you provide 0, 0, 0, it won't be the center of the scene. It will be the center of the object. All right. So it's like apply force, but with different coordinates, local coordinates. And apply local impulse, it's like apply impulse, but with local coordinates. I know that was a lot. If you have one thing to remember, we are going to use apply force. And you don't need the other ones. Maybe apply local force so that you can use local coordinates. Why not? We are going to use both, actually. Because, yeah, it's exactly what I said. All right, cool. So let's go. We are going to use only forces method, and we are going to start with apply local force and then use apply force. You will get the same result. You can do the same thing with both. So let's go. Go to your sphere, and at the beginning, so when the sphere is creating, we are going to push it in a direction. So we are going to use sphere body. We can do it after adding to the world, but I like to do things on the body and then add it to the world. It's just a preference. Apply local force. And for the apply local force, you have to provide a vec3, so it's a CanonJS vec3, and the local position on the object. Do you want to push it at its center, which is what we are going to do, or do you want to push it, I don't know, like on this part, and then it will start to torque, it will start to rotate. So yeah, we are going to provide some force. We are going to push it on the x-axis. So we can do canon vec3. You can test values here, but the right value for the lesson, so to get the same result as what I prepared, is 150, like this. And then we want to push it from its center. All right, we don't want him to rotate like that. It can be interesting, but it's a sphere, so it's not you won't see a difference. And we are going to use new canon vec3 0 0 0. All right, let's test. Suspense. And yeah, it's working. We are pushing the sphere at the start. Want to add more strength? I don't know, let's test this. Okay, even more. 600 maybe. And yes, it's working. You can create a cannon. That's cool. You can add bricks and try to make the bricks fall. You can create awesome game just with those simple steps. So it's working great. Next part, we are going to mimic the wind and apply a force on the opposite direction, but a small force, but on each frame, all right? Like if there is a constant wind pushing things just a little, all right? If there is a lot of friction, well, it won't budge, but if it's a sphere and you apply a wind on it, well, it will start to roll and roll and roll. Because it's on each frame, we have to move to the tick function, which is over there, and it's going to be before updating the world, all right? Before updating the physics world. So let's go, sphere body, and this time we're going to use apply force. It's just for the lesson purpose. We get exactly the same thing. Canon vec3, so we provide direction for this force, and we are going to do a force a lot smaller. So it's just a small pinch doing by the wind on the opposite direction. So it's minus 0.500. So we focus on the x-axis. And then you have to tell where in the world we are applying this force. Well, in our case, it's like doing the local force. We are going to apply it at the center of the object. And to get the position, because we are using apply force, not apply, which is the last one we saw. Sorry, I forgot. Yeah, apply local force. It's not apply local force, it's apply force. It can be anywhere in the world, but we want to do the same. We want to apply it to our sphere body at its center. So it's going to be sphere body, and we will get the position. Remember that the position is a vec3, so we can use it like that. Let's test it. So we have the initial impulse, and as you can see, it doesn't go as far as before because there is wind pushing back the ball, and because the ball can just roll, you can see that it goes on our left and it will continue without any, it's infinite. We don't have limit, we don't have a wall that block the sphere, so it will just go away, bye-bye. Okay, that's cool. So you can apply forces just like that. This is how I did for my car to jump when you're using the honk and stuff like that. Okay, that's cool. This is fine. It's working. We are happy, but right now we are only creating one object. So creating one object is quite easy. Managing dozens of objects can be a mess. How can we do that? We are not going to create each object manually. Well, it's the part where developers can go in many directions. All right. I will show you. It's not exactly the way I do, but it's almost it, and it's pretty simple to understand. Then you can go in any direction you want. So first we are going to get rid of everything. So the sphere, not everything, just the sphere. So we remove the sphere. All right, this is the sphere, the physics sphere. So we remove the sphere. We let the floor, don't touch the floor, and then we remove the sphere we can see in 3GS. So it's right below the test sphere part. Remove it. If you save, you will have an error on the tick because we are trying to get to update the 3GS sphere by using the CanonJS sphere. So remove this part too, and remove this part too, right? This part and this part, like this. We save. We have nothing, but at least we don't have any error. We are going to create a function that will create spheres. All right, this way we will just have to call this function to create new sphere. So let's go. I'm going to put the code right before the animate part because it's going to use the 3GS word. It's going to use the CanonJS word, so it's going to be here. And I'm going to call it utils, and I will put just functions that are useful for me. So let's create it. We are going to do const create sphere, and obviously we are going to create a create box later. It will be a great exercise. For a sphere, I provide 2 parameters. We can provide way more parameters, but I want to keep things simple, a little complex, but not too much. So when we are going to use the create sphere function, we are going to provide a radius and a position. I'm going to use fat arrow as always, and we can move forward. So let's go. We are going to do exactly what we did before with just small differences because we will have radius and position parameters. First, we are going to create the 3GS mesh. So let's go. Const mesh. We know how to do that. We have a lot in mind, but anyway, we know how to do that. It's a great exercise if you just want to practice. We're going to do new 3 sphere buffer geometry. It's exactly the same as before. The one we removed. We could have copy and pasted it, but it's always good to practice. New 3 mesh standard material, like this. And we provide a few options, like the metalness, 0.3, the roughness, 0.4, an environment map, and the environment texture is located here. All right. Pause the video if I went too fast. Then we say our mesh to be able to cast shadow. Why not? It will look better. And we can update its position. And instead of choosing a position, we are going to use the position provided in the parameters. Yeah, by the way, I used the radius here. When creating the buffer geometry, I use the radius. This part is important because we are going to change this part. We are going to have a problem. So mesh position, and I'm going to copy the position parameter. Position, like this. And then we can add it to the scene, like this. All right, let's try to do the rest and then create the sphere. We can just call the create sphere function, but it's a good exercise to try to do a bunch of things. And if we get something wrong, just comment the part that is comment parts, try, find the error. Now we are going to do the CanonJS body. We need a shape. So const shape equal new, and if you remember, it's Canon sphere. And we provide just the radius, which is the one we got from the parameter. All right, looks a lot like this part. Then we can create the body. I'm not going to call them like a sphere mesh, sphere shape, sphere body, because there will be only that inside that function. So I can just call them shape, body, mesh. It's okay. Equal new Canon body, and we are going to provide an object as parameter. We're going to use the same mass. We don't play much with the mass, but you can to see what changed. The position, actually, we don't really need to provide a position. I think we can get rid of it because we are going to update it after anyway. So let's put back the position anyway, just in case. And we are going to change it right after. Then the shape. So the shape, we use the shape we created right here. And if you remember in JavaScript, when you have the same name for the variable and for the property, you can just put shape. All right, we can do that. Let's do that. And then the material, and we are going to use the default material. And I don't think you have to provide this one actually. Maybe we can get rid of it. We can clean all of this later. So body position, and then we copy, just like we did, oh sorry, I wrote get world position. It's my suggest, my IntelliSense, I think it's that in VS Code. I don't know what I broke, but it's always providing me this get world position, get world rotation, stuff like that. So it's just position. Good job if you saw that I did a mistake here. It's just position. So here it's the same, so body position, and we copy the position from the parameter. Right? We copy the position from here. And then don't forget to add it to the world. World, add body, and we provide the body we just created. Like this. We save, no error, great. We don't have the sphere because we didn't call the create sphere, but as long as we don't have error, it's great. Maybe I went too fast, pause the video, get back to the video once everything is working. At least you don't have any error. What we are going to do now is call this create sphere. Just to create a sphere back, we want to see if our code is really working. So remove the 3GS sphere. We already did that, so ignore this part. We call the create sphere, and we have to provide two parameters. Remember, it's the radius of the sphere and its position. So we want to create the same sphere as before. So the radius was 0.5. And for the position, should we use a 3GS vector 3 or a CanonJS vec 3? Well, actually, we can just provide an object with X, Y, and Z. So thank you again to the guys that did the vec 3 in CanonJS and the vector 3 in 3GS. We can just provide an object with X, Y, and D, and we can copy the values of this object inside the body position and the mesh position. All right, it will work. Great. We can save. Finger crossed. Yeah, we have our sphere back. Great job if you got it on the first try. It's okay if you did mistakes. That was a lot of code. Find the error and get back to the video. But yeah, nothing is moving because we are not updating, we are updating the world, but we are not taking the coordinates and putting them back inside our 3GS world. So we need to do that again. But we are going to do things a little differently. We are going to create an array that will contain all the objects that need to be updated. So let's go. Const object to update. Self-explaining. I like those kind of variables. So at the start, it's empty. And when we create a sphere, at the end, we are going to save it. So it's going to be saved in object to update. But we need the body and the mesh in order to update them later. To provide those, there are multiple ways of doing it. I'm going to save them in an object. So inside our array, we are going to push an object. So my array push an object containing only the mesh, and the body. All right. I will show you the results. You can just log it, and we get an array containing an object, a JavaScript object with the mesh and the body. And if I create 3 spheres, I get 3 objects to update. Cool. By the way, if you have the same variable name as the property, as we saw many times now, you can just remove this and you get something like that. I'm not a big fan of this way of writing, but I wanted to show it to you anyway. We get exactly the same result. Okay, that's cool. That's really cool. You can see where we are going now. After updating the physics world, what we can do is loop through this array and update the mesh positions according to the body positions. So let's go. There are many ways to loop on an array. You can do for, you can do for in, for off, for each. There is maybe other ways, but these are the ones I know. There is a while, you can do a while. But anyway, I like to use the for off, which looks like this. It's just JavaScript. So it's my object, of object to update. So this is the array that contains all the objects to update. I'm looping on this array and getting each of its values if each object inside has this variable. So it's object. And then I will do the same thing as before. I will update the mesh according to the body. So object mesh, so this is this one, its position is going to copy the object body, so this one, position. Finger crossed, and it's working. So it was a lot of work, but now if you want to create a sphere, actually I create three spheres, you just have to provide another one. So let's say I'm going to move it a little. I'm going to do, I don't know, like 2 and 2 on the X and the Z. And it's working. And you can create many like this, maybe 3 like that. And it's working great. Okay, let's just keep 1 for now. We're going to have more fun shortly. Right now, we're going to add it to that GUI because I want a button. And when I click on this button, it creates sphere. And if I just smash the button, well, it will create many spheres everywhere, and we are going to burn our computers. Great. Don't burn your computer. So yeah, let's go. We are going to move up to the GUI part. And it's where things are getting funny. Because we want to call the create, it's there. The create sphere function, we have to provide parameters, and this create sphere is not inside an object. If you remember from the debug, when you use GUI add, you have to provide an object and the property name. It can be a function, and this will create a button inside the tweaks, like this. The problem is that create function is not inside an object. Create sphere is not inside an object. So we are going to use the same technique as we did for the colors. We are going to create a debug object. I'm getting tired here. Equal an object, and this object purpose is just to exist and to have an object in which we put everything we need so that it's inside an object. So let's go. We can then create a function in it. So it's going to be debug object. It's going to be the same name. I'm going to use create sphere. No parameters. I just want to be able to click to call this function, and it will create spheres randomly. And here we can just call, or you can do that like log create a sphere. So before really creating one, we can just do that. And then add it to the tweaks by doing debug object create sphere. All right, for now, it has nothing to do with our real create sphere function. But as you can see, we get a button. It's not working. Oh, I did a mistake. Give me a moment. Index at line 8. Oh yeah, sorry, when I wrote debug, it added a dependency. And we get something like that, all right? And when I click on it, as you can see, I get the log create a sphere. So the debug part to create a button tweak is working. We can now, instead of doing a log, we can do create sphere. So now it's the real one, it's the one over here. And we are going to provide some parameters. And we're going to provide the same parameter actually for now. It's going to be x0, y3, z0. We save. So when we click on it, we are going to have a new sphere. Let's test if it's working. Yeah, it's working. But wait, what's that? Well, that's funny. We're creating spheres perfectly, one on each other. So we are doing a pile of sphere. Maybe at a moment they will fall, but it's so perfect that they can stay like a long time, one on each other. So let's add some randomness. I'm gonna put some line breaks. You don't have to do it. It's as you prefer. Me, I prefer like that. I don't like really long lines of code. I like long variable, but not long lines of code. For the radius, well, I'm going to do math random multiplied by 0.5, so they are not too big. And so we will have random radius. Then we can provide a random position on the X, and I'm going to use math, you know this one, random minus 0.5. So we get as negative as positive. So it goes from minus 0.5 to positive 0.5. You know this one. If you watch the previous lesson, you know this one. And then I'm going to add more amplitude by multiplying the result of this part by 3. And then I can just take this formula and use it on the Z. I'm not changing the Y, but you can play with the Y too. All right, click on it. Cool. Go ahead, smash that button. Be careful, you might have performance issues at a point. Right now it's working fine. I have a pretty good computer, so it seems to be working. But anyway, as you can see, we can have a lot of fun and move the camera and see everything being created. Well, that's cool. That's really cool. It's important to have fun when doing those kind of projects. Long project, if you're not having fun, you won't get the project done, at least not in time. So yeah, let's optimize things a little. Maybe you saw that a few things are not optimized, and you're right. If you don't worry, we are going to see how to optimize those. First, let's get back to our, where is it? Create sphere. We have a lot of code. And as you can see, we are creating a buffer geometry and a standard material with each sphere. And we can use the same one because they have the same shape and the same material. So we are going to move those outside of the create function. So let's go. We know how to do that. Cut this part, so the sphere buffer geometry, and you will do const sphere geometry equal this geometry. And then you can replace the part you removed by sphere geometry. We can do the same for the sphere material. So it's going to be sphere material equal, and we can get this part and move it there. And then because we removed it from here, we have to put it back. Oh, sorry, I missed the parentheses. Be careful. We get something like that, all right? And because there is not much code here, we can remove the line breaks, all right? Take it slow. We just took the new sphere buffer geometry and put it inside this variable, and we moved this new mesh standard material and put it in this variable. This way, all the new spheres will use the same geometry and the same material. But we did a mistake. If I save, oops, radius is not defined. All right, here we are using the radius parameter here. How can we do that? So we have different geometries because they have a different size, but we are creating the geometry before. See the solution. We are going to use 1 as the radius. All right, just 1. As you can see, we are going to have a problem. If I use 1, okay, all my geometry have the same size, but not the shape inside the physics world. But at the end, I see only big balls that all have the same size, which is wrong. What I can do, instead of changing the geometry, because it's the same for each sphere, I'm going to scale the mesh. And I will do mesh, scale, set, and use the radius like this, because the base has a radius of 1, so I can just scale the mesh instead of changing the geometry, like this. And we get the same result, but only 1 sphere buffer geometry and only 1 mesh standard material. The performance is much better right now. And you can start again to create many, and the GPU won't work that much. Be careful, the physics is on the CPU, and the render is on the GPU. And one can make the whole frame rate drop. But we have to optimize both of them. You're going to optimize the physics part too, a lot. Okay, that was a great exercise. What you can do now is pause the video and do the same with boxes. All right, you keep the sphere, the create sphere, all we did here, but you create the same for boxes, and you provide like random boxes with different values. We're going to do it together, but if you want to practice, if you're not too tired of this long lesson, you can do this exercise. Okay, let's do it together. So if you did great job, that's a pretty hard exercise, but let's do it together. We're going to do the same, and we're going to use a box buffer geometry and a box shape. All right, I put the links as always in the links panel. So let's go. I'm going to duplicate all these parts. I think I will let the sphere, okay, let me see. We're going to add a sphere here so we can differentiate them. I'm going to take from the geometry, the material, the create sphere, and I'm not going to create a new one here. Then I'm going to put myself below and do box like this. All right, to a singular, singular. Okay, and I duplicate everything. And I get something like that. So now I have the box, I can remove this. Everything is called sphere, so I have to change all of these. Hang on. I let the create sphere, and now I'm going to create all the function and stuff like that for the box. Okay, let's go. First, we need to create a box geometry. So we can change sphere to box. If you're using Visual Studio Code or great editors like this, when you select a word, as you can see sphere, you get a highlight on other words that are sharing the same syntax, same word. So you can see that there is a lot of spheres everywhere, and we need to change those. So it's going to be box geometry, and we are not going to create a sphere buffer geometry. We're going to create a box buffer geometry. Be careful, the parameters are different. We need to provide the width, the depth, and the height. Like this. Sorry, the width, the height, and the depth. Then we can create the material. It's going to be the same material. We could have used one material for both the sphere and the box, but it's already pretty hard. It's okay to have two materials, 3 with the floor. It's okay. But if you want to optimize this part, do it. So here we have nothing about sphere. Then we have the function. So we can use create box. The parameters are going to be different. We are going to have the width, the height, and the depth. Because I want the width, the height, and the depth to be different, so it's not just cubes, it's going to be boxes with different various shapes. Okay, cool. So height, depth. Then we can create the mesh by using the box geometry. Then the material by using the box material. And then we can scale it, but be careful, there is no radius. We have a width, a height, and a depth. Like this. All right, I think we're all good here. Then we create the shape, and this time we're going to create a box. And I'm going to do a mistake. I'm going to do width, height, and depth. It doesn't work like that. In CanonJS, creating a box is not like creating a 3JS box. And I need to draw a few things to help you understand this part. So I'm going to do a box that looks like this, like this, like this. All right, that's not bad. All right, not bad. When you want to create this box in 3JS, you provide a width, you provide a height, and you provide a depth, like this. All right, I'm going to put D for depth, width, and height. In CanonJS, when you want to do that, you have to do it differently. You have to start from the center of the cube. So it's going to be somewhere, I don't know, maybe over there. All right, so it's the center of the cube. We have a cube that looks like this. I think it's around here. And you will provide what we call the half extent. It's what goes from, I'm going to use this, the center to a corner of the cube, like this one. This is called the half extent. And the half extent, so it's going to be a vector 3, 2. And if we go like, I don't know, maybe this, sorry, width, then the depth, it will go to this part. So the face on the depth is going to be D. And then the height, which is the part on the top, right here, somewhere over there. Height, like this. All right, so in a way, it's just the width, the depth, and the height divided by 2, because we are starting from the center of the box. Okay, that's all. That easy. So we need to provide half of it. So it's multiplied by 0.5. You can divide by 2 if you prefer. I just like to multiply by 0.5. And I think it's good. Let me check if there is other sphere references. No, I think it's fine. Maybe I missed a few parts, but anyway, we can go back to our code. We can add it to the .GUI. Yeah, I think it's good. So same thing here. We're going to duplicate the create sphere. And I'm going to call it create box. Yeah, obviously. So create box. Be careful with the parameters. They are not the same. We need to provide a width, a height, and a depth. I'm going to put from 0 to 1, so it's just a math random. So this is the width. Oops, sorry. This is the width, this is the height, and this is the depth. And then the position, we will put the same random position as for the sphere. All right, so they pop at the same place randomly. And then we can add it to the debug panel by calling GUI add debug object create box. Whew, that was a lot. No error. I'm surprised. If you have error, just fix the error, and then you can click on create box and there is an error. All right, so what did I do? It's with the way I created this box, the half extent. Oh yes, I know. You cannot provide the values like the width, then the height, then the depth of this half extent. It has to be a vector 3. My bad, I forgot about this. So those values, you just cut them and you create a canon vec3 and then you provide those values. So it's the x, the y, and the z of this vector 3, and this vector 3 is this famous half extent I talked about. So it's this part, right? The purple one, the purple vector. Let's try again. So I did a mistake, you see? I'm clicking and now it's working and it's looking great. Or is it? We are creating the boxes, but look at the animation, it's really strange. Can you guess what is wrong right here? If you make, I don't know, I don't have any rectangle. If you make, I'm going to take this. If this falls on this, right now it's doing this. It's supposed to do this. It's supposed to rotate. What we are missing here is the rotation. How could we miss that? Well, it's because we were using spheres. And you can see a perfect sphere. If it's like this or like this, you won't see any difference. So our spheres were not rotating, but we could not see it. So it was okay. But now that we have boxes with different shapes, we can see that the rotation is not working. So we need to fix that. To do the rotation, well, we updated the position. As you can see, it's in this part. We update the position by copying it. You can't use the rotation property of the mesh. We need to use quaternion. And luckily for us, it works just like the position. So you can just duplicate this part, take the position of both the mesh and the body, and use quaternion. All right, it's exactly the same. We are copying the quaternion of the body inside the mesh quaternion. We don't care about the rotation property. The rotation property will be updated anyway, but we don't care about it. We have quaternion, let's use quaternion. And now it's working great. It's perfect. And you can mix spheres and boxes. And it's looking good. Sometimes I have frame rate drops. Be careful, we have performances issues and we are going to improve that soon. Now, perfect. So let's talk about performances. We've been doing the lesson for a long time. Maybe you need a break, take a nap, go watch a movie, stuff like that. Anyway, you will need to have some focus for what's coming. It's not that hard, but it was a long lesson. So take breaks. Let's do performances update. Let's improve the performances and talk about the broad phase. When testing the collision between objects, CanonJS is currently taking, let's say we are going to add more. Currently want to know if this one collides with the rest, it will take this ball and test it against this ball, then against this sphere, then against this box, then again this one, then again this one, then against this one, then again this one. And then the next one is going to test all of them. So each object is testing if it's colliding with every other object. It takes a long time. It's a lot of work for the CPU because it's the CPU working here. And it's bad for performances. Meaning that if you have, let's say, a pile of objects here and a pile of objects here, and you cannot, they are too far to be colliding with each other, currently each one is testing with every other object, meaning even the objects on the right, which is wrong, but at least it's straightforward. We call this phase the broad phase, all right? The fact of testing with which one, it's called the broad phase. And currently, CanonJS is using the naive broad phase, and we have access to other broad phase. So currently, CanonJS, maybe I said 3JS. So CanonJS is testing every bodies against every other bodies, all right? We have different broad phase solution. We can use the grid broad phase. The grid broad phase will do something like that. It will divide the scene in a grid. In every direction, like that, and then like that, in every axis, so like that, so we get a lot of those. When testing one object, let's say we have an object in here. This object will be tested against other objects in the same grid cell, like this. We are going to create, I don't know, a cylinder, stuff like that. Also the one on the side, so if there is, I don't know, a cube here, let's say we are testing only this cube, it will be tested on the same object, of the object on the same cell, but also the one on the neighbors, but not the one further. So if you have, let's say, a sphere here, this box won't be tested against this sphere. And if you had, I don't know, a pile of sphere here, many spheres, this box won't test if it's colliding with those, all right? This is a good way of doing things. The problem is that if there is a sphere traveling like really fast like that, so the previous time the sphere were there, and the next time the sphere was already there, so it went from there to there, it will not collide because at any moment it was on the same cell and on the neighbor cell, and you will have a bug when the sphere just go through your cube. All right, so it can happen, which is why by default it's the naive approach. All right, but still the performances are going to be way better. And we have another one which is called sweep and prune, which will test bodies on arbitrary axes during multiple steps. I just wrote it down. I do not understand it. All right. I just know that it's better. It's even better than grid broad phase. It depends on what the objects are doing exactly, but I know that it's better than grid broad phase and naive broad phase in many situations. And you can still have a problem where an object traveling too fast won't be colliding with other objects. All right. It can happen. So be careful with that. But it's so much better in terms of performances that we are going to use this one. It's the sweep and prune. If you're interested in that, there is many articles. I wrote them and I didn't understand. I'm not really good at math and stuff like that. So let's update it by doing. It was a lot of talking. By going back to the world, and we're going to do world, broad phase, equal, and you have to instantiate a broad phase. So it's going to be canon SAP, so sweep and prune, broad phase. And you have to provide the word as the parameter, like this. We save. It seems that we get the same result, and we actually get the same result. But I'm going to add a lot, and no frame rate drop. It's just better for performances. My objects are not traveling too fast, so there is no problem, no error in the collision, everything is going fine. So always update it if you can, and if your objects are not traveling too fast. And if it's okay that an object does sometimes go through another object, well, we don't care, use it. All right, let's continue our optimizations with the sleep part. Even if we are using a better broad phase, each object will be tested. Maybe not against each other object, but anyway, CanonJS will go through each object and test it against one that are not too far or stuff like that. So it's still a lot. But right now, as you can see, my objects are not moving. So why would I test this object if it's not moving? Well, what I can do is to tell that this object is sleeping. Do not wake him up. Just let him sleep and do not test him. And you can do that when the body is going slow. At a point, it's going so slow that we are going to say, okay, this one is sleeping. Let's let him sleep. And it won't be tested or updated with other bodies. And if something push that body, I don't know, there is suddenly a finger pushing it, well, it will wake up. And then we are going to start testing it again. And if it stops, okay, let's sleep. And this will drastically improve performances. It did a huge difference on my portfolio. I just added the sleep property and the performances were so good and started working on mobiles and stuff like that. I was so happy. I played on my portfolio for hours, as always. Okay, to do that, it's really simple. You just have to do word allow sleep equal true. And that's all. We did it. So if you had performances issues, you will see that you will have a frame rate improvement, and we can add a lot. So we cannot see that they are sleeping. Actually, there are ways of knowing when they are sleeping and even see that they are sleeping, but it will take too long. So just trust me, those ones are starting to sleep. Not this one, because they are colliding. He tries to fall. It's pushing this one. So they are still moving. So it's okay. Things are working properly. But this one is sleeping. This one is sleeping. This one is sleeping. This one is sleeping. The spheres, I don't think so, because they are still moving. They can just roll, which is great. It's realistic. All right, cool. By the way, you can also change the sleep speed limit, meaning at what speed we consider that it is sleeping. There is also a sleep time limit, because the Canon GS just wait like maybe 1 second before saying, okay, this one is sleeping for sure. So if it's going too slow, depending on the sleep speed limit, and for something like 1 or 2 seconds, okay, this one is sleeping. We won't do that. You can just trust the basic settings, and it will be fine. Okay, that's cool. So we did huge optimizations just with few lines of code. All right, the broad phase, the sleep, and it's much better. That's cool. The next part is about events, and we are going to do a cool exercise. We are going to add sounds. We can listen to events like collide, sleep, and wake up. The one we are interested in is the collide event. We are going to know when objects collide with each other. And when they collide, we will play a sound. We just play a small talk. And this talk, we'll hear it when things are colliding, which is exactly what I did for my portfolio. So let's go. Be careful. Some browsers like Chrome prevent sounds from playing unless the user has interacted with the page. And by interactions, it means like clicking somewhere, touching the screen. I don't think scroll is considered as interacting. Well, for us, it's going to be a click. All right. So if you don't hear the sound at first, just click on the scene anywhere, just click on the website and you will start hearing the sounds. I know we won't talk about that. So it's Google doing its stuff. Let's not talk about that. Okay, cool. First, we're going to load a sound, and we have a sound. It's located inside the exercise static. So it's inside the static sounds, and we have a hit sound. I'm going to use my earbuds right here to listen to the sound. All right. You're supposed to hear the sound in the video. Right? If it's not working, I probably messed with something. Just trust me when I say it's working. Anyway, you will do it on your computer and it will work. Okay? So I needed to test if it's working. Let's see how it goes. So let's go. I'm going to put the sounds right before the textures. It's not that important, but let's put it there. So it's going to be sounds. We are going to load only one sound, and I'm going to call it hit sound equal new audio. And we provide the path to the sound by doing sounds/hit/mp3. All right, this is just the JavaScript way. All right, this has nothing to do with 3GS or Canon GS for the moment. We are just creating an audio element, and then we are going to create a function, play hit sound. As always, I'm using fat arrows, and this function will just play the audio. All right, to do that, we just call the play method on the audio element. We save, no error, great. Cool, let's go forward. Now we are going to listen to the collide event. We are going to do it only on the boxes, and once it's working great with the box, we are going to move it to the sphere. All right, so just focus on the boxes. We can do it here. Right after creating our body, we will listen to the collide event, just like we can do it in JavaScript. We are going to do add event listener. Then we provide the event name. It's collide with 2L. Maybe I did a mistake here. Oh yeah, it's collide with 2L. My bad. So it's right inside this code. And when this event happens, we provide a function that will be called. So it's going to be play hit sound. All right, we can test it. Add one box. Follow me on this. You will have bad surprise if you do more, that we will fix later. Add one box. And right now I'm hearing it. I don't know why Chrome is trying to load the favicon, so the error you get here, you can ignore it. I hope you won't have this error and Chrome will fix that. But for me, it's just that Chrome is trying to load the favicon. There is no favicon. Each time I'm playing the sound. I don't know why it's doing that. So normally you should hear the sound. And because you click on the create box button, we had the interaction, the user interaction, so we can play sounds. All right, so everything is working fine. Add many boxes. Yeah, that doesn't sound right, isn't it? We get some tac, 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 tac. It's regular. It doesn't correspond. It doesn't match what's happening in the scene. Well, the problem is that we are asking the sound to play. Where is it? It's here. We are asking the sound to play, but maybe the sound is already playing. So if the sound is already playing, because right before there was a collide event, well, you're asking a sound to play, it's already playing. All right, it will just continue to play until the end. Maybe it went to the end, and then you ask him to play. Well, at that exact moment, the sound will restart from the beginning, right? So it can only play if it's ended at a moment. To fix that, there are many ways of fixing it, but there is a really easy one. It's to reset the sound to its start. And to do that, we can do hit sound, current time. So it's like moving the sig bar of your music, all right? And we put it at the beginning of the music. So it's hit sound, current time equal 0. Test it, 1 or 2 boxes. Yeah, that's better. Add many. Oh, that's bad. We have a very regular and it sounds like because there is a lot of collide event happening, even if the box just slightly touch the ground, like it bounces like this slowly, you will get a lot of collide event, so even if it's slow. What we need to do is get the strength of the collision. And if this strength is not that high, we just don't play the sound, all right? We just play the sound if there is enough impact strength between objects. To do that, what we can do inside our play hit function is put a variable right here. You can call it as you want, you can call it event or stuff like that. I like to call this one collision because inside of this variable, we will get informations about the collision. So you can just console log it, just add once to focus on what we get. And as you can see, we got 4, a lot. So as you can see, we have too many collisions. Even if it's a slight and small collision, we get an event. And we get a lot of data here. And inside the contact property, we have access to a function. It's a very long function, just like I like them, which is get impact velocity along normal. All right, that's a long name that will provide you the impact strength. It's more like the speed, but we can consider it like the impact strength. All right, let's test it. So inside the collision object, we have a contact object. And inside that contact object, we have access to the get impact. I will write it with you. So it's get impact velocity along normal, parentheses. And we get, oh, we have to add one box. I forgot. Yeah, see? seems to be working. We get information about the strength of the impact. Great. What we can do now is test, is only play. So we're going to save it. I'm going to do const impact strength. We save the value we just logged. It's just to have it somewhere. And if the impact strength is above 1.5, you can choose different values. You just have to test it. But I think 1.5 is fine. So the last one, as you can see, are below 1.5. I don't want to hear them. I want to hear the sound when it's below 1.5. And you play the sound like this. Add the box. Working fine. And it's working just great. Okay, I'm fine with it. The result is great. I can move forward. So it's working great. The problem is that the sound is really regular. It's always the same sound and it feels strange. What you can do is add some randomness to this sound, to this its volume. You will do hit sound volume equal math random, because it's from 0 to 1. The volume property is from 0 to 1. So don't try to go above 1 like 4. We'll get an error. It's not logical. Then we add it. Yeah, we have the same result, but the randomness in the volume make it more realistic. And it's working good. Really great. All right. If you want to go further, we are not going to add more, but if you want to go further, I recommend you to first, you can create different sound, all right? Because when you hit the same object on the same thing, usually you get a different sound because of material, stuff like that, physics. So you can maybe have 3 different sounds that looks kind of the same, but they are not the same, and play one of them randomly. The next recommendation is to add a very short delay where the sound cannot play again after being played once. It's because sometimes when one object touch the floor, it will trigger 4 events at once. All right, you can't do much about it, but let's try to add just a small delay. Like, okay, you don't play for, I don't know, maybe 10 milliseconds or something like that, maybe more, like 30 milliseconds, so that you don't try to replay the same sound on the same frame. All right, and in addition to random value, you can also scale the volume. So currently we have a random value, but what would be great is to use the strength impact to also change the volume. Like if it's a strong impact, we play the volume at 1. And if it's a small impact, we play the volume at something like 0.1. All right, if you want, you can pause the video and try those stuff. We're not going to do it because the sound is great now and it's not the purpose of this lesson. And we have other things to see. Okay, great. We are almost there. See the loading bar here? It's almost done. We did it for the box. What we can do is do it for the spheres, and it's going to be very simple. We just have to take this body add event listener collide play hit sound and move it to the sphere right here. So we are listening to the collide event on sphere body, and we play the hit sound when this happens. Let's test. So maybe you will hear this sphere, maybe not. Me, I'm hearing it because Chrome considers that I'm allowed to play sound on this domain, all right? But maybe you won't hear it because you didn't interact with the scene. So click anywhere. Actually, just click on the Create Sphere button and you will hear the sound. And it seems to be working. Okay, that's cool. It was easy. Oh yeah, see, now it didn't work. I don't know how Chrome managed this. But anyway, I got an error. The sound didn't play because Chrome wanted me to interact with the scene. I interact, I click somewhere. Sorry, I don't want this dictionary. I add a sphere and now it's working. All right. Let's move forward. This one is quite fast, don't worry. We're going to learn how to remove things because maybe you change, it's another level, or the ball went too far out of the stadium, you want to remove it. Well, how do we remove things? We are going to create a reset button that will just remove everything in the scene. So let's go back to our GUI, create a new property inside the debug object. It's going to be debug object reset equal a fat arrow like this. I'm going to put just reset in here, so a log, and then you can add it to the tweaks. It's going to be reset, all right? It has nothing to do with 3JS or Canon.js. We just created this reset method inside the object. And when I click it, I get the log. Okay, great. What we need to do now is remove everything. And to do that, so we have to loop through our objects to update. This is where we save all the objects. So let's go for const object of objects, just like we did in the tick function. And then we have to remove its body. So it's going to be object, so world remove body object body. But to do it really properly, you can also remove the event listener. To do that, we do object body remove event listener. It's the same event, so you provide collide, and you also have to provide the function. So for us, it's play hit sound. So it's exactly the same like this, but instead of add event listener, we use remove event listener. It looks the same as JavaScript events. Then we can remove the mesh from the scene, from the 3JS scene. So remove mesh. This one is remove body. This one is remove mesh. And we do scene, remove, object, mesh. Just like that. Did I do a mistake? I don't know. Let's add some. All right. I reset. Everything is gone. Quite easy to remove things from the 3JS scene and from the body. Okay, looking great. That was fast. And I think it's the end. We will do a few things, but it's the end of the main lesson. You did it. Congratulations. Stick with me. We just have a few things to talk about, but you did it. And you learned a lot, how to create objects, how to create new objects, how to organize your code with just one array, how to update the world properly, and then update your 3JS scene. So it's great. You learned a lot. But yet there are other things you can do. And the first thing I want to talk about is the constraint. You can create constraints between two bodies. Like you have, I don't know, a sphere and a cube. It doesn't matter. You can create constraints between them. The first constraint is the hinge constraint. Just like a door. Like this can only rotate like a hinge door like this. All right. We won't do it. All right. I just want to tell you that those exist if you need. You can create a distance constraint. You have your sphere, you have your, I can use those objects. We have those, and you create a distance object between those, meaning that they will always keep the same distance. If there is one being pushed away, the other one will keep the distance with it, and you can have good result. I don't have examples, but you can. You can lock constraints, which means that we kind of merge bodies, and they will always move like this, even when rotating. So it will be always like this. If the one is colliding, I don't know, with the mic, the other one will still follow, and it will be just like one body. And finally, you can use a point-to-point constraint. It's like when you glue things at a very specific point. I don't know how I look with those, like playing with toys. So you glue them at a very specific point. Thing can rotate. I mean, if they have room, they will rotate. And they will, if one is moving, the other one will be moving. So it's at a very specific point. All right. That was funny to do. Next thing is about classes, methods, properties, and events. We covered a lot, but there is more. What I always recommend is just to have a look to the documentation and just look at all the classes. All right. It won't take hours. You just have a look to each one, and okay, there is a box. Okay, there is this thing about broad face, and maybe you know down that you need to dive deeper into those. You have cone equation, that's interesting. You have constraint. All right, so we can have some constraint. I always recommend to do that, just to read what you can do. It's okay if you don't know how to do it, but just knowing that you can do it will help you if you need those. All right, so always read the documentation. The documentation isn't awesome. Like, it's okay. We can have a lot of information, the method, the properties, but it lacks more information, more description, stuff like that. But you have access to examples, and I put the link as always. So it's like the main website of Canon.js, and you have examples. Let's say you want to create a car to play on your website. Should remind you of something. And here is an example. And if you want to know how they did that, just watch the code. There is not so much code in here. Just copy and paste the JavaScript into your VS Code or any editor, and you will be able to understand how this can work. All right, cool. The next part, we're going fast here. The next part is about workers. Workers are, let's try to explain to you. The component of the computer doing the physics is the CPU. All right, the WebGL is mostly handled by the GPU, but the physics is handled by the CPU. Currently, all your JavaScript is being done like everything like this. The physics world, everything is being done by the CPU. It's a lot for the CPU, and it can quickly overload, which is why when you have a lot of things going on here, at a point we have a frame rate drop. It's probably not your GPU, it's probably the CPU. Maybe it's your GPU, it depends on your computer, the GPU and the CPU. But anyway, usually when you have physics and a frame rate drop, it might be from the CPU. The solution is to use workers, because your CPU can do one thing at a time. It's not exactly true, because your CPU can handle one thing at a time. It can do it like really fast, but your CPU most likely has multiple like we say core, we say threads. It's more like core. Your CPU can do, when you run your JavaScript, there is one thread taking care of all your JavaScript, meaning your JavaScript here, but also the physics part. With workers, what you can do is take a part of your code and put it in another thread of the CPU. You will just separate your code, do one part on the main thread and do another part on the other thread. And we usually put the physics calculations in this other thread. All right. This is called workers, and you have an example with Canon.js. As you can see, it's working well. There is a lot of cubes. It's working at 60 frames per second. And if you watch the code, all this part is just JavaScript, but being handled by another thread. All right, it's inside a worker. And you can do that if you want to improve performances when using physics libraries. All right, next thing is about Canon ES. Canon.js hasn't been updated for years. All right, it's working well, but still it can be improved. But unfortunately, it has been updated for years. If you watch the log, I don't think it has been, probably even for you. Fortunately, some people forked the repository and started working on update, and they fixed a few things and added some update, which is great. Thanks to them, we can have new things and bugs fixed and stuff like that. And we are going to use it. And you will see that it will be easy and it will just work like that. First, we need to get rid of the previous Canon.js library. To do that, you can do npm uninstall -- save Canon. All right, it's like npm install save Canon, but we put uninstall. You press enter. Just wait a few seconds. It will remove from the dependencies Canon.js. Then you can install the new Canon.js, so npm install -- save again Canon, but now we are going to add -es, and you can just put it like this and press enter, but maybe you should use the same version as me and provide the 0.15.1 to make sure that we are using the same thing. We press enter, just wait a few seconds, maybe a few minutes if it's a little heavy. All right, let's start the server again, so npm run dev, like this, and you will get an error. Why? Because we are trying to use the old Canon.js library, and we don't have it anymore in the dependencies. What we need to do is use the Canon ES, and be careful, we don't import it the same way. We have to do import all as Canon. We save, I refresh, and we get the same result. All right, but we have updates. I won't talk about updates, bug fix, stuff like that. You can just watch, I put the link as always in the links panel. Just watch the logs, watch the description, what the community did, but still it's great to have an updated version. All right, next part is about emo.js. So emo.js is harder to use, I think, and to implement in your project, but it has more features. All right, we use Canon.js because it's simpler and I think it's better for beginners like us, but Emo.js can be great too. First, it's a portage of a very well-known library, which is called Bullet. It's a very old and well-oiled physics engine, so there is all the experiences inside of Emo.js because of that, because it's a portage of Bullet. It has WebAssembly support. I'm not going to explain everything about WebAssembly, but it's a low-level language with better performances, and it's supported by most recent browsers. All right, maybe not a few years old browsers, so be careful, but still the modern browsers are supporting WebAssembly. It's more popular, I think. I'm not sure of that, but I think more people are using Emo.js, and the examples inside the 3JS documentation are using Emo.js. And it supports more features. So you have more constraints, options, stuff like that, which kind of get harder because you have more things to think about. Next thing is about Fizzy.js. I hope I'm saying it right. Fizzy.js. We talk about Fizzy.js at the beginning of the lesson. Fizzy.js will ease the implementation of physics in a 3JS project. It uses Emo.js, and the idea, and it works with workers natively, so we'll have better performances without doing anything. The idea is that instead of creating one mesh and then one body, you will only create the Fizzy.js box mesh, and we do the same work we did before by creating the 3JS version and the Canon.js version. So we have nothing to do, which is great. Why didn't we use this? Well, it's because I wanted you to understand how physics work and also to have more control, because you are limited by what Physics.js provides you. And if you have a bug, because there is like a layer above the logic of having a physics world and a render world, a 3JS world, it will be harder to understand where is the problem. All right. But you can try it. It's a great work, a huge community working on this Physics.js. Okay, it's the end. Adding physics to a project is a long process, but it can improve the experiences drastically. Look at my portfolio, look at Angry Bird, there are many other experiences. Just watch the examples in the 3JS website. We see a lot of physics. Not that much because it's hard, because you can have frame rate issues, but still it's great in terms of experiences. So if you can, try to use it for good purpose, obviously. And I see you in the next lesson.